Hello, my name is Pilar and I belong to SINAI group at the University of Jaén. And I'm going to present my participation in Cantemist challenge entitled Extracting Neoplasms Morphology mentioned in Spanish clinical case through word embeddings. First of all, we would like to show the tags in which we have participated. As we know, Cantemist consists of 3 tags and we have participated in the first 2. Starting with the tags of entity recognition, our group has presented a machine learning system based on neural networks. Using a bidirectional LSTM network with a conditional random field. As a novelty, we have included the combination of several word embeddings in this network. The word embeddings that we have studied in our approach are the following: fast text embedding trainer over Wikipedia, contextual word embeddings, which essentially model word has a sequence of characters, and Spanish medical embeddings. These last word embeddings are trained by ourselves, extracting the corpus from different sources of information. The pre-processing carried out to train the word embedding consists of converting the text to lowercase, remove tag, remove URL, remove multiline. The algorithm used to train the word embedding is fast text. And finally, you can find the parameters for the training step here. Now we want to show you the architecture followed for the implementation. For the development of the network, we have used the Flare library of Python. We also wanted to highlight that the training set has been expanded using the #1 development set. We have chosen this set because it contains more sentences and more labeled entities. Finally, we have used as a development set the #2. The result of TiNet can be seen in this table. On the one hand, and taking into account the F measure, the use of word embedding obtained value close to 84%. Word embedding trained on Wikipedia obtained the worst result. Moreover, word embedding trained by ourselves reach a bit higher values. On the other hand, the combination of word embedding helps to recognize entity in a more precise way, reaching 85%. For the second task proposed by Cantemist is normalization. We must assign a single ICD-0 code to each previously detected entity. To accomplish this task, we have development and a supervised and a dictionary-based method. This method consists of 3 steps. In the first steps, we created a dictionary with ICD-0 code and their description. In the second step, we calculate the López-Ubeda distance between the previously recognized entity and each dictionary entry. For example, the distance between the entity cancer and the description neoplasia metastasica is 20. And finally, we sort the dictionary by distance and return the entry with the shortest distance. The results of TiNet with this tag are shown in this table. It should be clear that we use the output of the previous tag to assign a code to each entity. This means that we use the same methodology for each of the output of the previous tags. Since the best results of TiNet in the previous tag were using combination of word embedding, it was not surprising that in these tags we are obtaining the best values, reaching almost 76%, and 74% in the non-metastatic category, taking into account the FM measure. To conclude our presentation, we would like to highlight some conclusions. The probability of recognizing a specific entity in a text often increases as different types of representation of that word are combined. It's important to generate results according to the domain and the tags to be addressed. Since contextual word embeddings are robust against misspelling words, we assume that they could be very useful for the name entity recognition tags in clinical text. We must carry out a more in-depth analysis of the result with the GOLD test. This is all. Thank you for your attention.